Hey guys, so I had some homework questions in chapter 9.2. I understand it's a really hard section, but once you get it, we will be using it in chapter 10. So make sure you understand it because we're going to be using it later. All right. So in number 1 on the homework, it says the critical value of t for a 90% confidence interval with degrees of freedom equaling 4. Okay, so first thing you have to do is convert that degrees of freedom to n, because we don't use degrees of freedom in the math we use. So we say, okay, n equals degrees of freedom plus 1. So n equals 4 plus 1 is 5, right? Okay, then you go to your calculator, right? You type stat, then you scroll over to the right to test, and then you scroll either down to t interval or you press the number 8, which is easier, so just press 8 once you get there. It gives you this, all right? So you have to fill in all this information first. The input, you gotta make sure it's on stats, because if it's not, it doesn't even give you this list, okay? So the mean is 0, the standard deviation is gonna be the square root of n, and that's why we add 1 to that number, so the n we're using is 5. Once you scroll off of this, it turns into the decimal form. And then n is 5. Our C level as a decimal is 0.9 or 0.90. And then you hit calculate, right? And then it gives you this interval as an answer, 2.13 and 2.13. All right, that's just your standard deviation, 2.13 standard deviations to the left and right. So that's our confidence interval. All right, so that's the answer. T equals 2.13. Okay, so it's similar, or the second part of this problem says basically the same thing. 98% confidence interval, degrees of freedom is 112. So we know our n is 112 plus 1, or 113. So we just change these few numbers. Press stat, test, 8. Then make sure it's on stats. The mean is 0, the square root of 113. N is 113 with 0.98 this time. You hit calculate. It'll give you two different numbers. Well, these are the same, but 2.36 for this one. So the answer to this is 2.36. Okay, so for number 8, it says the doctor wants to estimate the mean HDL cholesterol of females, whatever that is. How many subjects are needed to estimate the mean within 3 points? Okay, so that's our error. With a 99% confidence, assuming that the standard deviation is 17.7. So if we go back, the equation for a z-score is x minus mu over the standard deviation, but the standard deviation for us is now a sample standard deviation. So that's the equation for a sample standard deviation. Usually we have sigma here, right? Now, another thing we're going to change is x minus mu. We're going to use e instead. So our error is going to go up top. Because remember, the difference between the mean and that upper or lower limit is the error. So that's why we can do that. All right, now if we solve this equation for n, we don't really have to do any work after we do this. We get n equals, so the number of people we need to survey is z alpha over 2, so that's our z-score for our error, times the standard deviation s divided by e squared. Okay, so if you take the time to solve this equation for n, little n, you'll get this. All right, now the only thing we don't have right now is that z-score, but that comes from this, okay? So to find that, all you need to know is here, this is telling us that alpha is 1%. All right, because if you remember, we have this error margin. Okay, so out here, we don't want that. But if alpha is 1% and 99% is in here, that means this is split of 1%. So really it's 0.005, 0.005. Those add up to 1%. So our z, that's why it's alpha over 2 and not just alpha. All right. So if you look at your table, all right, you find 0.005 on your table. Now it's kind of halfway between two things here. And then you follow the table backwards. So we get 2.57. All right, now since it's in between these guys, I'm going to put z alpha over 2 is 2.575. Just to be safe, all right, because it is in between those two. So we can estimate it to be that. Then you just plug in all your numbers and you get your answer. So we have n equals 2.575. S is given as 17.7 divided by E is 3 squared. Then we get our answer. So we have 2.575 times 17.7 divided by 3 squared. So it says 230.81. We can only survey an integer of people, so we're going to say 231 there. All right, same thing here, but we have a different confidence. Now, on the review, I made a little table for you guys to fill out, and you're finding all these confidence intervals using the table backwards, okay? So you have this one already, I believe. Should be on that table. When I did this, I got a 1.645. And then we just plug into this equation all over again. But the only difference is that 1.645 goes here. Okay, so we have n equals 1.645 times 17.7 divided by 3 squared. We get 94 or 95, as we can say for that one. All right, so in the end it asks what happens when we lower our level of confidence. Well, what happens is you need a smaller sample, because if you don't want a confidence level that's really high, you don't need to survey as many people. That's how it goes. Okay, so problem number 10 says find the margin of error, so we're finding E this time. We can reuse this equation, but we're going to have to solve for E. For a 95% confidence interval. So again, it's giving us that Z value, all right? Alpha is 5, half of alpha is 2.5, so you go to your table and you look for 0.025 on the table, then go backwards to find the Z-score. When you do that, you will get 1.96. So Z alpha over 2 equals 1.96. But this time we're changing sample sizes and finding the error for each of those sizes. So if we take this equation and we solve for E, to do that, we square root n, right? We times E and then divide by that square root n. So it's going to give us this. Z alpha over 2 times standard deviation divided by square root of n. That's all we do, okay? So right away, we just find these. E equals, our Z is 1.96 times standard deviation 90 divided by the square root of 400, which is 20. We'll just write this one out too. E equals, for a larger sample size, 1.96 times 90 divided by the square root of 1681. Well, in the end, we can answer C too. We're dividing by a bigger number, so therefore the error is going to be smaller. You could look at it that way. The larger your sample size is, the smaller the error is going to be. We'll write that in a second. So we get 1.96 times 90 divided by square root of 400 is 8.82. Error is fine to have a decimal. The second one, the only thing we change is the bottom, which is the square root of 1681, is 4.3. Okay, so there it is. Our error decreased by more than half with that larger sample size. And this is 4 times the sample size. So larger sample means less error. All right, so I hope you guys are doing well. I know this is quite awful, the online class thing, if you're not used to it. I'm not used to it at all. Luckily, I have experience in making these videos, but in the end, it's terrible. So hope you guys can bear through it. Like I said, chapter 10 is going to be a lot like this. We're just using some different terms and getting into the real statistics. Okay, so have a good day.